Hi guys! Today we're going to be taking some notes over solving systems of linear equations by graphing. So all I need you to do is follow along and write everything that I write. So number 1 here says system of equations, and that's a set of at least 2 equations that contain the same variables. So we're going to write 2 and variables right here. The second one says systems of equations work together and deal with the same unknown values. So they work right here together and deal with the same unknown values. Number 3, a solution to a system of linear equations is an ordered pair that makes both equations true. So right here, we're going to write ordered pair. And number 4, systems of equations can have a 1, 0, or infinite solutions. So, one way to solve a system of equations is by graphing. So the first thing that we're going to do whenever we're trying to solve these is we're going to graph the first equation. Step 2 is to graph the second equation. And step 3 is to record the point where the lines intersect, which means where they cross. And step number 4 is we're going to check the point by substituting for x and y in each equation. So we can check our work here to make sure that we're having the right answers. So if we go to our next page, you'll have a little chart right here that has different lines. So right here, do you see how this says intersecting lines? What that means is that these lines are crossing each other like this. And so that means that their solution is going to be right here where they cross. So the number of solutions that they're going to have is only 1. Now here we have parallel lines. So there's a line going here and a line going here. And you'll notice that the lines don't touch each other. So if they don't touch each other and they don't cross, then they can't have any solutions. So our answer here is 0. Now, this one's a little tricky because it looks like there's only 1 line there. And that's because there are 2 lines and they're actually graphed right on top of each other. So they're essentially the same line. And what that means is that every point of this graph, here, 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 and so on, I could keep going. All of these points, just like the one over here, are actually touching each other. But because they're the same line, that means they're going to have infinite solutions. And if infinite is kind of hard for you to write, you can always draw the classic infinity sign. Don't mind mine being wonky. So, with that said, we are now going to move on to some practice problems. So here on our first one, I'm just going to move it up just a little bit so it's easier to see. We first have to graph these lines. So I'm going to start with my first line, which is y is equal to negative x plus 4. So the first thing that I do when I graph a line is I'm going to look right here at my y-intercept, and I'm going to graph that first. So it says it's at a positive 4, so I'm going to put a dot at positive 4. And then it says my slope is negative x. And remember, if there's no number there, then that means there's a 1. So I'm going down 1, boom, over 1 every single time. Down 1, over 1, down 1, over 1, down 1, over 1. And you repeat that until you run out of graph. And for this case, I'm going to go up 1, over 1, up 1, over 1, 1 over 1. And again, I could keep going till I run out of graph. And then all you do whenever you're graphing lines is connect all of your dots. Boom. So now that I've graphed my first line, I'm going to go ahead and graph my second line. So my second line, my y-intercept is at +1. So I'm going to go up to +1 and put my dot there. And then my slope right here says it's 2. So that means I'm going to go up to 1, 2 over 1 right there. Up to, make sure that I'm on the right line. 1, 2 over 1. Boom. And again, up to 1, 2 over 1. Boom. And then I can go the other way, down to 1, 2 over 1. Down 2 over 1. And I could keep going, but I'm going to go ahead and just draw my line here. So you'll notice that the point that they cross right here, and I know my graph's a little bit small, but if I were to actually really look at what that point is, I'm going to write it as an ordered pair because that's actually my solution. So because they cross like this, the first thing I'm going to write is that they have one solution. One solution. And then I have to write my solution as an ordered pair. And remember, your x goes in front and then your y goes second. So I'm going to see how far over and then how far up I went to get this point. And if I look, I went over just 1. I went over 1. So my first x, because this is my x-axis down here, I'm going to write a 1 here. And then up, when I go up, I said 1, 2, 3. So I went up 3. And so this is actually my answer, 1, 3. That's the solution that you're going to need to make sure that you know how to put down to make sure that you're getting the right answer. Alrighty, I'm going to go ahead and move on to our next example problem here, which is this one. So the first thing I have to do, remember, if you're not sure, go look at the steps we just wrote down. The first thing I'm going to do is graph my first line, which I have my y-intercept as -1. So I'm going to put my point there. And then my slope says I'm going down 1 and to the right 2. So I'm going to go down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. And again, I can go the other way and go up 1 and then over the other way 2, up 1 over 2. And I can keep doing this down 1 over 2 until I've run out of graph. But I'm going to leave it there and go ahead and connect all of my dots to make it easy on myself. Now I have to graph my second line. So my second line, my y-intercept's at -4. So I'm going to go ahead and put a dot on -4. And now it says that my slope is +1 over 4. So what that means is I'm going to go up 1 over 1, 2, 3, 4. And right here, I'm obviously going to be crossing this other line. So again, I'm going to go up 1 over 1, 2, 3, 4, and then I'm going to run out of graph. So again, I'm just going to go ahead and connect these 3 points since my lines intersect there and I don't really need to go any further. So again, because my lines are crossing this way, that means that the first thing I have to write is that they have only one solution. So now I have to figure out where that point is. And so I'm going to go over again on my x and look how far over I went. And so do you see how there's a 4 right here? So that means that my first one is going to be 4. And then I have to see how far down this is. So I'm going to go down 1, 2, 3. So since I went down 3, I have to write this as -3. All right. So on to our next problem. So right here we have x plus y is equal to 7, which I know can be a little bit confusing. Oh, I'm on the wrong one. I'm sorry. We're actually going to do this one right here, which is y is equal to x plus 6, and then y is equal to x minus 2. So again, I'm going to graph my first one, which my y-intercept is up here at a 6. And then since there's no numbers in front of my x, I know I'm going up 1 over 1 every time. So I can just put that on the diagonal, and then I can go the other way as well. And again, I'm not going to make all the dots because I don't need to. So I'm going to go ahead and draw my line. The next line is at -2. Boom. And again, I have the same slope here where I'm only going up 1 over 1 every single time, up 1 over 1. And what you'll notice is that these lines, because they have the same slope, are never going to actually touch. That makes them a parallel line. So these lines are never going to cross each other. And since they never cross each other, then I can't have a solution. So I'm going to write no solution. And then I'll write that they have parallel lines. All right, for our next example here, I have, again, x plus y is equal to 7. And then I have y is equal to x minus 5. So I know this one's going to be tricky, so I'm going to just help you out, and we're going to graph this one like it would normally be graphed, which is, if we change this one up, it would be y is equal to negative x plus 4. Okay? So again, I'm going to graph my first one, which I'm just going to go ahead and graph this one. That's all the way done for us. And so my first one's going to be at positive 4. Positive 4. Right there. And now that I have that graphed as positive 4, what's going to happen is I have to do my slope, which is negative x. So what you'll notice is after I wrote these equations are the exact same. So what that means is that I'm not going to need to draw 2 lines. I'm technically only going to have to draw 1. And so it's going to be down 1 over 1, down 1 over 1, down 1 over 1. And then again, up diagonal the other way. And if I were to graph this second line, this one would be right on top of this line. They're the exact same line. So when they're the exact same line, this has infinite solutions. So what you can also write if you want to write infinite solutions is, again, you can draw that infinity sign like that, and then you can tell me that they're the same line. Alrighty, we're going to have one more last example where, again, I'm going to do the same thing to this first equation where I have to move my x over to the other side. So I'm just going to subtract my x, and what I end up with is y is equal to negative x plus 7. And again, don't stress out too much about that one because we'll go over how to move these, but in short term, it's going to be like a one-step equation. So I'm going to graph my first one, which I have a negative 5. So I'm going to put my dot at negative 5. And then my y-intercept is, or my slope is 1 over 1 because there's nothing in front of that x. So again, I'm just going to go up 1 over 1, and I'm going to draw it on the diagonal, which is the easy part about going up and over. Only one is that it's going to look the right way. All right. Again, make my line. And then I'm going to graph my second one, which is the one I converted here, which is a plus 7. So my plus 7 means I'm going to go all the way up here. And then I'm going to graph my slope, which is negative x, which means I'm going to go down 1 over 1. And again, when you go down 1 over 1 and you're only going 1, you can just go on the diagonal, make your line super easy. And then since they already cross, I'm not going to worry about graphing the rest of my line. I'm just going to go ahead and draw my line. So again, my solution is where they cross. So I'm going to have one solution. One solution. And then I'm going to look at what point I have here, and I'm going to draw it as an ordered pair. So I went all the way over to this 6 right here. So my first one is going to be a 6. And then I'm going to see how far up I went, and I only went up 1. So my ordered pair is 6, 1, and that is the answer. All right, the very, very last thing